Chapter 4, question 7 reads, for a harmonic wave given by y equals 10 times sine of 628.3x minus 628.3t, determine the wavelength, frequency, propagation constant, angular frequency, period, velocity, and amplitude. Okay, so the equation we're given is y is equal to 10 times sine of 628.3 x minus 6,283 times t. Now we're usually given the wave equation in a slightly different form, and I'll write that out real quick. We're given a sine k, where that's the propagation constant, times z, which is the phase, plus vt. But this is not in that form. There's an equivalent form that I'm not sure if the book actually gives, but you'll see that they're equal forms as we work this problem out. We can use a sine times kx minus wt, and you can see that this inner part matches this much nicer than this does. Okay, so back to what the question's asking. It wants us to find the wavelength. It also wants us to find the frequency. And this is the temporal frequency as opposed to the angular frequency, which you'll see the difference in a second. The propagation constant, which is k. The angular frequency, the period, the velocity, and the amplitude. Let's see if you can still see this. Okay, you can. So, some of these values you can clearly match up, so you can see that this A, without getting too mathematical or into the physics of it, you can just see that it matches. So the coefficient in front of the sine is the A, which is given as 10. So right away we can call that 10. And there's two other numbers that are given directly. The constant k is given in front of x, so we know right away that the constant, or the wave number sometimes it's called as well, is 628.3. And we're also given this value in front of the t, which when we match it up to this equation, we see that it's the same as the angular frequency. So we know the angular frequency right away, 6,283. Okay, so the rest of the values will take a little bit of manipulation to solve for. So the first step, I'd like to find, using the wave number, we can actually deduce what the wavelength is. The wave number is actually just it's the number of waves per unit distance. So one way we can write it is actually just, it's 2 pi over the wavelength. Okay. And we know that these two are equal here. So to solve for the wavelength, we would just multiply both sides by the wavelength and then divide by 628.3. So our wavelength is 2 pi over k, which is 628.3. And this gives us a value, let me put this in the calculator, of 1,000 0.01 centimeters. So that's our wavelength, not our K. So let's put this up here, 0.01. Alright, so that solves part A. Part B asks us to find the frequency, not to be confused with the angular frequency, but there is a relationship between the two. The frequency is simply, well, the angular frequency is 2 pi times the frequency. That's the definition of angular frequency. So now we can do simple algebra to isolate f, so divide both sides by 2 pi. So f becomes 6,283 divided by 2 pi. And put that in the calculator. And we get a number very close to 1,000, and this is going to be in the unit hertz because it's a frequency. So I'm going to round up to 1,000. It actually comes out to be 999.97, but we'll call it 1,000 hertz. So this gives us our frequency, 1,000. We have K, we have W. Now we need to find the period T. The period is actually just 1 over the frequency, and we know the frequency, 1 over 1,000. Now this is measured in seconds actually, so we can call this 0.001 second, or if you want to convert it to milliseconds, we can call it 1 millisecond. Whatever form you want is up to you. Alright, and the last section, we already have the amplitude. We figured that out earlier, so we don't have to worry about that, but the velocity is the last one. Now the velocity is defined by the frequency times the wavelength. So basically how fast, the wavelength is a distance and the frequency is how the time it takes to cover that distance, so that gives us a speed or a velocity. And we know f and lambda already. F is 1,000 and lambda is 0.01, which leaves us with a speed of 10, and the unit for this is centimeters per second. So that's it. These are your two answers for the period and velocity, and here are your other answers for the other variables. Alright.